Afternoon. May I request all of you to please take a seat? The dignitaries are already on the dais. Kindly take seat. Nobody is listening to me, ma'am. May I request the chairman, sir, to please welcome the speakers of this session with floral bouquet, please. And I request Director ICAR-CIRCOT to felicitate Dr. Chaudhary. He has visited this institute for the first time. Thank you, sir. I request Chairman, sir, to take over the session, please. Delegates. क्या सर? ये माइक को? No idea. ये नहीं हटेगा सर. Hand mic. Delegates, please settle down. Session is about to start.
Friends, may I have your attention, please? Dr. Patil, Dr. Chakravarti, Dr. Chaudhary, thank you very much. Now the house is in order. Now, madam, you can take over.
Please take over.
Okay.
Session.
So, friends, we have got two very important presentations today before we break for lunch and also go to the exhibition. And those will be presented by two of our DDGs, Deputy Director Generals in the headquarters. The first presentation will be by Dr. Chaudhary. Dr. S.K. Chaudhary is our DDG Natural Resource Management in the headquarters. He has got a long and varied experience on water management, soil management, and several other aspects. And he has also been associated not directly with this institute, but also cotton cultivation. He comes from that particular area only, to be precise, from this particular state. So, Dr. Chaudhary, first of all, thank you very much for being here and also agreeing to deliver this particular talk. Without taking much time, I shall request Dr. Chaudhary to please make the presentation. Over to Dr. S.K. Chaudhary.
Thank you very much, Chairman Saab. Dr. Himanshu Pathak ji, Dr. Eric, my colleague, Dr. Jha, esteemed colleagues, Dr. C.D. Mai, and all very, very senior people around. First, I place on record my sincere thanks to the organizers for inviting me for very, very important lecture. When we talk of cotton, as told by our chairman, esteemed chairman, I am from the area where cotton cultivation is very common. Rather, I grew with cotton. So, cotton, mostly in rain-fed areas, always experience the fury of climate, the weather, and therefore, farmers' problems with cotton are many in numbers. although it's not possible to leave away cotton cultivation, but really speaking, there are huge number of problems, and there is also policy paralysis. And that's why many times you will find farmers speaking that cotton cultivation is not very economical, mainly because our poor levels of yield levels are very poor, particularly in India compared to China or any other country. That's why the issue of cotton cultivation, cotton productivity is one concern. Secondly, cotton is a crop, fairly rain-fed crop, roughly 70% cotton grown on rain-fed areas, and uncertainties associated with rainfall are so large and they are growing every day. Excess water is a problem, moisture stress is also a problem. Therefore, it is very difficult to find the way out, find the middle way, and go for cotton cultivations. Not only research, but also the developmental activities, the policies, they have their own challenges. And fortunately, we have one project called National Innovations in Climate Resilient Agriculture, where we learn so many things. And every time we learn, we come up with some kind of strategy. We call it adaptation strategy mostly. And therefore, some way out is there, and that is helping us in cotton growing areas. Friends, you are very well aware. I do not know whether the dais is able to see. No, probably they are not able to see. नाही त्याच्यावरती माझाच फोटो येतोय. Anyway, if you correct it, that it will be better. So, okay. So global scenario, if you see the global scenario, globally, temperature rise is a common phenomena. Everybody, we are aware of this. Compared to pre-industrial era, it is roughly 1.1 degrees centigrade more. And with the current rate of emission, slowly and steadily by 2050, we will be witnessing an enhancement of 1.5 degrees centigrade in temperature. And by end of this century, it will touch 2.5 degree to roughly 4 degrees centigrade. And you are aware of the Paris Agreement, everyone, 2015, when almost all the countries, they agreed to reduce the emissions and control the global temperature rise around 1.5 degrees centigrade. How to achieve it, how we are going to deal it with, and because of this, Government of India has several commitments at the global level, including the commitment of emission neutral country. The year 2023, recently, we have witnessed very hottest August month in last 175 years. This was the hottest month in monsoon season. And August is a very, very critical month for cotton, be it rain-fed or in some irrigated areas also. So August is the most difficult month, and here we are witnessing more and more temperature rise. Projected climate change, if we talk of Indian context, so you compare present, actual versus projected, very close to the end of the century, there would be a great change. These two graphs, two maps, they show very distinct differences in temperature regime as well as the moisture regime. Means rainfall situation and temperature situation will not be the same as we have. And that's why we are witnessing very intense and frequent heat waves, and we all are aware of this. Temperature increase is a common phenomena, particularly in the cotton growing belts, whether it is in Gujarat, Maharashtra, parts of Karnataka. The temperature rise, temperature increase is really affecting the cotton cultivation. As such, almost all type of cultivation, but cotton cultivation mostly. Rainfall enhancement, unless you have some kind of paired row furrow system or region furrow system, you will not be able to manage cotton crops properly. And frequent failure of cotton crop because of intensive rains is also very common. Vidarbha witnesses once in every 3 years, farmers have to go for a resowing. And resowing is a very, very expensive event in the case of cotton. And therefore, inter-annual variability, this year, next year, next to next year, great inter-annual variability. You cannot have definite trend, and therefore farmers, every time they are losing so many things, and on ground, people say cotton cultivation is just like gamble. बोलना अच्छा नहीं लगता, but this is a reality. I'm cotton farmer, that's why I'm telling this. On behalf of farmers also I'm speaking this. So it is just like a gamble. And if you see the cotton cultivation of India and the figures given by COCPC, which provides the figures in the cotton production and consumption over the period of time, if you see the trend, we are the highest cotton producing country. Roughly 40% of world cotton we are growing in our own area. But productivity, as I said in the beginning, is much less than 500 kg per hectare. From 1 hectare of land, if you are getting less than 5 quintal of yield, then what will be the fate of farmers? How much benefit they will be able to accrue? And cotton is not a routine type of crop. You require very intensive input there, intensive care also. And the weather and climate-led vagaries, they make it very difficult at any stage. And most critically, the first picking stage, first time you pick the cotton, that time, that is the most sensitive stage. And initially also for better development, if an event of 10 millimeter or 15 millimeter rainfall happens in a day, farmers are really worried. If the rainfall event is 10 to 15 millimeter for one day, then cotton, you require very special kind of attention to the cotton crop. And cotton in India, which engages huge manpower directly or indirectly, and total value chain, if you see, many people, 60 million plus people, they are involved. That's why this is very, very important crop for us. But more importantly, since the crop is very, very much grown on rain-fed areas, therefore, rain-fed area requires special attention, and policies very specific to rain-fed area, for particularly cotton, they are very, very important. If you see the 10 different phenological stages of cotton and the values, if you take both the key values, every time you will see that P8, 8th stage, where first time you are picking the cotton. So this first picking to second picking in between, that stage become very, very important. And this is the stage where most of the climate related problems, they also happen. And therefore, they are coinciding and they are leaving farmers sometimes clueless what they should do. And that's why our contingency plans, our measures, our advisories, they are timely, but provision of timely inputs and provision of timely support is very much essential and required at this stage. Climate change and cotton cultivation, as I said, often right from seeding, right from initial stage up to harvest, every time farmers need to be alert. It is not rice cultivation or it's not wheat cultivation once you sow and then revisit the field after 1 month or 2 months. It's not so. It's everyday business, day-to-day business. And that's why the cotton farmers, they are really very, very careful farmers. Morning and evening, both the times they go, they have to check every ball, every leaf, every plant. They need to talk with the plants. And therefore, the climate change impact need to be understood thoroughly to have better adaptation strategies. If you see the impact of elevated carbon dioxide, now elevated carbon dioxide and elevated temperature, these two are the main concern. Rainfall, of course, is one of the concerns, but enhancement in carbon dioxide concentration and temperature, these two are main concerns for us. So, being C3 plant, cotton, wheat, rice, sunflower, these are very, very sensitive to climate change. Also, they are involved more in emissions, greenhouse gases emission, compared to maize or sorghum or sugarcane. So, enhancement of carbon dioxide up to 900 ppm, it helps. But enhancement in temperature it reduces the cotton performance beyond 28 degrees. Therefore, two different kind of scenarios where enhancement in carbon dioxide concentration and enhancement in temperature, one scenario. Second scenario, enhancement in carbon dioxide concentration but not proportionate enhancement in temperature. These two different scenario produces two different kind of results for the same variety, same area, same soil type. So this needs to be understood thoroughly. And optimum temperature, phenological stages wise, if you see, so based on our very fundamental and basic researches in this country, also countries abroad, we found that at germination stage, temperature should be around 28 to 30, and accordingly, the seedling stage, square formation, and ball size and retention stage, temperature should always roam around 25 to 28 degrees centigrade. If temperature rises beyond this, then it affects adversely the cotton cultivation and cotton development. Now, this elevated carbon dioxide concentration and elevated temperature in cotton yield, we have very systematic experiments in this country through our NICRA project and also some of the agricultural universities and also some of the agricultural institutes, non-governmental institutes, they are also working in this area, and we found that 40% yield enhancement is possible if temperature is 1 degree centigrade and elevation of carbon dioxide very close to 450 to 500 ppm. But if temperature rises beyond 2 degree, then there is definite decline in cotton yield. Also, this enhancement in carbon dioxide concentration, after that it stabilizes and then declines. This decline starts from 600 ppm onwards. Therefore, the carbon dioxide concentration present levels, even present level goes up to 50 ppm extra, probably it will be favorable for cotton. But temperature is another important factor that really reduces the cotton yield. The same thing, if enhancement carbon dioxide concentration and temperature is there, then how water use efficiency behaves? Because cotton is important crop of rain-fed, 70% of cotton in rain-fed area. So in rain-fed areas, from every drop, every percentage of moisture conserved inside the soil profile requires to produce more and more cotton yields. And this is possible if we are able to manage ambient temperatures around 28 degree, which is beyond our control sometime. But there are possibilities, there are intervention, or there are some adaptation measures by which we can do this. Now, second graph on the right-hand side, it shows both in irrigated condition as well as rain-fed condition. In both the conditions where carbon dioxide concentration enhances and temperature goes beyond 30 degree, then definitely farmers are going to lose the cotton crop. And this reduction sometime, being a cotton farmer, I can understand, sometimes from 1 acre area, it is very difficult to get 1 quintal of yield. कभी कभी ऐसा भी होता है कि 1 एकड़ में 1 क्विंटल भी नहीं मिलता. This is सच्चाई, this is reality. And this is the reason. Wherever temperature goes beyond 32 degrees, it often happens during the monsoon season. And if such kind of days, number of days are more, then there will be definite yield reduction in case of. Second problem, Helicoverpa, you all are aware of this cotton bollworm. Now, cotton bollworm is the problem emerged at higher scale during last 5 years. Before that also the problem was existing, but pink bollworm and all, they came very recently, just 5 years or 6 years back. Before that, whitefly was a problem. Now, how this optimum range, when I say when temperature is very close to 28 degree or 25 to 28 degree and carbon dioxide concentration less than 400 ppm, that is the most favorable condition for Helicoverpa. That is the most favorable condition for cotton bollworm. And if this condition, if carbon dioxide concentration increases or temperature increases, in both the situation, the attack and impact of Helicoverpa is also going to reduce. So optimum development at ambient carbon dioxide concentration and temperature means 350 and 15 degrees centigrade, and reduced development of Helicoverpa happens when there is shoot up in both carbon dioxide concentration and temperature. These are the basic studies from our fundamental and basic researches we carried out in this country. Similarly, enhanced temperature and cotton. In the case of whitefly, yet another problem of cotton cultivation, and it was witnessed first time in Punjab, and a lot of area was really damaged. Now also this threat is not over, and some of the parts, in some of the areas, this problem is also very, very common. So whether it is nymphal survival percentage, nymphal development, and also if you see the total population of whitefly, everything is maximum. It is favored when there is cool temperature and moderate carbon dioxide concentration. So this also favors the problem of cotton whitefly. So you require definite kind of interventions in this. Your strategies should be very clear, and it is possible to control to some extent. It is not purely by agronomic approaches or agronomic strategies. You require multi-pronged approach to control both the problems, whether it is helicoverpa or it is whitefly. For both the problem, you require multi-pronged strategies, including the strategy of best economic practices, also climate resilient technologies or climate resilient intervention, and you require some kind of chemical-based interventions in this. Now let us see the situation of GHG emissions. Now whenever we talk of climate change, we cannot ignore this part, be it rice, be it wheat, or be it cotton, because these three are important, and fourth is sugarcane. These four crops are very, very important from climate GHG emissions are concerned. Now GHG emission, if you see, and I will come on the life cycle analysis also, what happened, how GHG emissions happen from cotton field, you will see that it is possible to reduce GHG emissions significantly with interventions. And some of the strategies, although they are mitigation strategies, we are hesitant to talk of mitigation. Some of the strategies which have co-benefits towards mitigation, adaptation strategies, but co-benefits towards mitigation, they really help in cotton. And cotton crop can be broadly supported by this. So this is the crop, and many of you are aware, rice is the first candidate, which emits more greenhouse gases, followed by wheat. But in the case of cotton stands third, although sugarcane is written third. But if you see the height of the graph, then you'll see cotton is the third. So rice cultivation, which contributes roughly 52% of the GHG emission. So total crop-related emissions, if you see, the cotton stands to very close to 12% emissions. Now, if we are talking of cotton, then it is also important to compare cotton cultivation or emissions from cotton with the other fibers. If you just see the other fibers, whether all synthetic fiber, nylon, acrylic, or polyester, and if you see the complete life cycle analysis, then probably they are the much bigger emitters compared to cotton. And cotton stands second from the bottom, and it is less than 2. So cotton versus other fibers, and this is, we are calculating in terms of carbon dioxide equivalent GHG per kg of fiber. From 1 kg fiber, for producing 1 kg fiber, how much carbon dioxide is emitted. That point of view, cotton stands much less. But if you see the life cycle analysis through complete value chain, then cotton cultivation is just 12%. Out of the total emissions from cotton, the cotton cultivation is just 12%, but other sectors like manufacturing and then transportation, distribution, and packaging, if you compare with them, probably the cultivation part is much less, and maximum is from manufacturing and use phase. These two phases, they emit more and more greenhouse gases compared to cultivation. But it does not mean that cultivation is very safe and we should not take any strategy for that. This is the life cycle analysis, and I just trying to give how much reduction is possible with what kind of strategy. The left hand side on the y-axis, if you see, there the figure, this much reduction is possible. By optimizing nitrogen, you can reduce up to 2.5% to 2.8% gases emission from the cotton fields. By optimizing nitrogen rate with special kind of fertilizers or specialty fertilizers or new fertilizer formulation where nitrous oxide conversion is less, there also there is a possibility that the emissions can be reduced by 13%. Drip fertigation, drip fertigation is yet another technique, and fertigation with no diesel or crop response or following the solar irrigation in cotton, there is a strong possibility these emissions can be reduced. Therefore, now from the government point of view, from the policy point of view, it is very much essential to encourage farmers to go for drip fertigation, not only drip irrigation, but drip fertigation with split application of nitrogen that not only enhances the use efficiency of water and nutrient, but also helps reduce the GHG emissions significantly. Fluxes, if you see, in the case of fluxes also, rainfed is a positive point. Rainfed cotton is a sink of carbon dioxide, and roughly 4 ton per hectare sequestration is possible through rainfed cotton. If you see the projected impact of climate change on the productivity of irrigated cotton, rainfed, as I said, rainfed, there is a possibility that you can make it a sink, but in the case of irrigated cotton, there is a possibility without adaptation, yields are likely to decrease in 4 states where mostly irrigated cotton is practiced. It is Punjab, Haryana, and also Rajasthan, and parts of Gujarat where irrigated cotton is followed. But in the case of rainfed states, there is projected impact which is positive, and yield shall increase in many other states by mid or end of this century. This is a very important message coming out of this. And if you talk of adaptation gains, total adaptation gains due to technological intervention for futuristic kind of scenario, then it is very clear that, both in rainfed as well as irrigated area, if you go for adaptation strategies or adaptation intervention, you have fair opportunity of reducing GHG emission and making cotton as a futuristic crop. And some of the successful interventions are in agronomic practices, intercropping is there, and also you have multi-tier systems. They are all very successful. AICRP on cotton is demonstrating all these strategies, climate resilient strategies through different states also. Seed cotton yield for drought management techniques. Drought management techniques, just like broadbed furrow or region furrow or chemical interventions of salicylic acid or glycine or some other kind of intervention, they really help to create better situation during the drought period. Now, broadbed furrow and high density planting, they really help us in reduction of GHG and also enhancement of yield, and in particularly the broadbed furrow system, it helps a lot. Nutrient expert is one kind of tool developed by our AICRP on cotton, and it shows very successful use of this nutrient expert system for small fertilizer management. And this is very successful, and this kind of other expert systems and decision support systems are also developed. They are very much helpful. Irrigation methods and fertigation schedules, as I said, micro irrigation and drip fertigation, it helps, and particularly when drip is associated with split application of nitrogen, it helps a lot. And also some of the places it was found that biochar is also one of the very good intervention for this. Whitefly, one expert system is developed by AICRP on agrometeorology, where daily weather data and whitefly population prediction along with the farmers' wisdom, the farmers' input, whitefly population in the field and pesticide applied. If we provide this much information, then advisory can be generated, and this advisory is really helpful and supporting the farmers of Punjab to a great extent. Some of the policy imperatives which are required: first, conservation tillage. By conservation tillage, you can reduce 8 to 10% gases emission, and you can make climate smart crop. You can call cotton as a climate smart crop, but for that, you require state level policy intervention and state level scheme where the conservation technologies, not only conservation tillage, but overall conservation technologies or resource conservation technologies, you should have one kind of scheme on that, particularly in Maharashtra and Gujarat. Neem-coated urea, although people start criticizing, but really it helps in reduction of GHG. Only thing, the coating quality and the oil quality of coating of urea, that is a different issue. But as per the Government of India norm, if you are able to coat it properly, then there is a great opportunity to reduce. By nano-urea, again, many controversies can be there, can be debated, but certainly it reduces the nitrogen application because of less nitrogen application, less possibility of nitrous oxide emission. And also broadbed furrow and micro irrigation, this already I have discussed. So these are some of the policy imperatives where state government and central government required to chip in and come up with some doable things where Government of India and respective state governments can help the farmers to become more climate smart in the case of cotton. Some of the issues which already we have discussed, but certainly the basic and fundamental research is required to enhance the resource use efficiency, particularly the photosynthesis efficiency, nitrogen, water, energy, and also coming up with some doable practices which really help to reduce the GHG emission and making climate smart crop, cotton as a climate smart crop. Breeding efforts are going on, whole CICR and universities and whole ACRP, they are doing this crop improvement program, and we are doing this for last so many years now. So trade discovery or genome, all these things are required. Conservation tillage practices, as I said, resource conservation technologies, state government needs to launch separate schemes for cotton, and this component need to be strengthened. Presently, we are talking only of the varieties, we are talking of plant protection measures, we are talking of the cotton marketing, but we are completely missing this conservation technology or resource conservation technology. And carbon credit can be extended further after rice and wheat, we can extend it to cotton because it's third important emitter of, and also this require kind of academic and scientific sensitization all across the cotton growing areas. So thank you very much. Thanks a lot.
Thank you very much, Dr. Chaudhary. You can take your seat. It is really a very comprehensive presentation covering all the facets of climate change and its impact on cotton. You also summarized what are the mitigation technologies which are available, what are the policy needs, and also going into details of how physiologically and other soil and water processes climate change is going to affect. Of course, friends, this is a really very, very important subject because climate change is no more that something is going to happen 10 years later or 20 years later. It is already happening, not now, even for the last few years we are observing that one. So probably our whole research as well as development efforts now should be directed towards resilience, and that's what one of the key words in your international conference also. So I'm sure there will be many more deliberations on this particular aspect, and you will be coming out with some good recommendations. So thank you, Dr. Chaudhary. Thank you very much for a very comprehensive presentation. Friends, let's quickly go to the next presentation, and probably this is the last presentation before we break for lunch. And that will be presented by Dr. S.N. Jha. Dr. Jha, as you all know, he is DDG of Agricultural Engineering. And today morning also he has made his observations about CIRCOT, cotton and all his other activities. Dr. Jha, yours.
Thank you, sir, very much for giving this opportunity. As you all know that India is one of the biggest, largest area and the largest producer in the world, around 5.8 million metric ton. Second largest in spinning, and 5,000 ginneries are working, and with 300 spinning almost mills. Contributions to GDP is around 2%, and 7% of industrial output of India is because of the cotton, you can say. So these things are not actually being highlighted. Every time people speak GDP and what is the contribution of agriculture and then individual sectors. Sowing window is very small, October to December. Farm size, of course, is small. And we know that our 86% of farm are small and marginal, so difficult in mechanizations and automations is that one of the things. We are moving, as I have so told in the morning, major point I have already told, the cotton mechanization have been done mostly I can say, only thing required the implementation by the majority of the farmer, and also require miniaturization of these machines for small holders. And land preparation we have, sowing machines we have, intercultivation, spraying, all these mechanical harvesting. Limitedly people are trying to do. All those machines are mostly from the other country, but not getting successful. Mechanical biomass harvesting we have also, and a lot of work we have done on biomass, or total use of the biomass of the cotton plants. About 72 cotton producing countries in the world is there, 25 are about having the mechanical picking and stripping out of 72. Developed countries, mechanical sowing, interculturing, operation, plant protection and harvesting are being done, and up to limited level. Increased cotton productivity is due to mechanization in USA and Brazil and Turkey, and we have one recent survey by the Government of India, Department of Farmers Welfare and Farmers, our DFW, that say that around 20% increase in production and productivity is because of the mechanization, and a lot of saving in water and many other things. That's why I say, why not we should try to increase the production and productivity for a few years using the mechanization and automation in any facet of agriculture. Increased cotton productivity will be there also. Mechanical harvesting, 100% is done in USA, Australia and Israel. And India, we are trying some mostly are 100% you can say hand picking only. Some hand pickers have been developed here, but again the performance is not good. Labor intensive picking operation, cost of picking is 10 to 15% of the total price of the cotton, that is around rupees 8 to 15 per kg. Drudgery is of course there, and increased input use efficiency is there. That we have to reduce. Improved productivity, reduction in the production cost is the need of the hour. And once the mechanization, automation is brought out, then only timeliness also improve the cost, reduce the cost and improve in the productivity. Improved quality. Many times people think that production and productivity is more important than the quality. Quality for any industrial material, raw material is more important than the amount. If the quality raw material is there, then only the quality product and value-added products can be developed. Improved farmers' income, of course, once quality is improved, farmers' income will automatically improve. Varieties, I have already told, not amenable for mechanization. A lot of points I have spoken in the morning, so I will not repeat. Tall variety, branchy variety, just like a brinjal plant, it is a cotton plant also. Wide spacing is also one of the reasons difficulty in mechanization. Less plant population per unit area, non-uniform ball distribution, non-uniformity in ball opening, multiple picking in practices. How we can have only one picking once, or at the most two. Ineffective defoliants, many machines which you have tested now, they say that if the defoliants are effective, then all the leaves of the plant can be fallen, and then the impurity in the harvest will be very less. And fragmented holdings is one of the reasons for less mechanization. Lack of 8 points causes in mechanical harvesting, and we have these kind of spindle pickers and strippers. Spindle pickers are having 12 to 15% trashes, stripping having 25 to 30%, and people are still working on this. So the CIRCOT and Bajaj company has developed some kinds of trash removers, up to some level, and they have got success. Dedicated lines of pre and post cleaning machines have been given, but that also requires some more purification so that the international level of trash content should be achieved. Handheld pickers, low picking efficiency is around 70% and ineffective due to choking of mouth, and of course trash content is there also. Developing amenable varieties, hybrids for cotton harvesting is must. Without that, probably we will not be able to do. Even if we develop the robots, they will be working 24 hours, but again efficiency will be less. As the efficiency means the per hour, how much amount that robot can pick individually, that has to be seen. Optimization of cleaning machinery for handling high trash content is also required. Establishment of demonstration and research facility at farmers field required. Again here we need a lot of efforts and finance. Acceptability in market for mechanically harvested cotton also. If people know, many times they are of the mind that they might have a very high trash content. So now we are also working on that, how we can know the trash content and quality of bale itself without doing anything. Automatically, non-destructively, instantly people can know, and we have partially success. Maybe some instrumentation can tell directly that how the bale which bale is having less impurity, whole bale, and then farmers and the purchasers will have more confidence in that bale. And HDFC technology are being tried, offset of the additional cost to be incurred at additional agronomic practices if we follow that. And cleaning machinery also required to be installed everywhere. That of course add to the cost. Vital development and mechanization is disjointed efforts. Lot of things I have spoken in the morning that have to be seen. Adoption of mechanization in sowing, planting, interculturing operation, plant protection, all these machines are here, but very selected people, farmers and entrepreneurs are using. So here again the extension work and some policy decisions are required to be taken by the government at a state level, of course at the central level. Picking machine, already we are harvesting and picking we are working. Cleaning and ginning operations have been worked already, and small ginners are also. These ginners should be installed at the production catchment, I say, so that the farmers can directly gin and then sell their produce based on the quality. Government initiative, of course, at their level, CIE, CIRCOT and CICR under NATP, TMC, we have worked. Initiative from private sector, Bayer, Crop Science, and many other companies has done. Bajaj Steel is very long-term partners, and they are doing well with us, and they have contributed a lot. Arvind Mills, spinning of machines, picked cotton. I will tell you the quality of fabrics, and also the one thing. Just a day before yesterday, I saw in the market that dhoti developed, sold by the manufactured by the Arvind Mills, one of the best dhoti of India, quality-wise. And cost is much less than many others. But many others take the higher cost because of the name of that company. Then adoption of tractor drone, all these I have already told. But there are certain issues which I would like to tell defoliants that required to be developed indigenously. Some defoliants I have been told that already developed at a foreign country and working very well. So here also we have to see. Here also policy decisions required some kind of permission, some kind of regulatory authority has to give him. Promising pickers technology, which I have told that these are the capacity and these are the things, but performance I have already spoken. Then trash content, hand-picked cotton, only having trash content of 1 to 2% on raw cotton. Machine-picked cotton having trash content 12 to 15%. Whereas machine-stripped cotton in India having 30 to 37%, but foreign companies having only 12 to 25 to 30%. So we have to improve further. High trash content in India, poor defoliation, main reason for less cost of our cotton. These are the additional cleaners for machine-picked cotton, and the people are working, and I think things will be improved in coming years. CIRCOT developed some stick machines useful for cleaning of mechanically picked cotton. 3-stage saw cylinders are used to remove sticks, burrs, large cotton. Fine trash removal efficiency is 50%. Fine trash is very difficult to remove, but it removes up to 50%. Stick removal is 87 to 90%. So very good machine, and it can be used by the farmers also. Cost is also not much. And short band cleaners, already I have told you can see by picture. It is a small machine. It can be utilized by even the individual farmers. Only extension and some kind of supports may be given to the farmers who are growing the cotton. Onboard field cleaner for a stripper harvest cotton. These are cleaning efficiency 55 to 60%. Then you can see that uncleaned cotton, cleaning by machine. The left side is uncleaned cotton harvested by machine, then cleaned cotton by our cleaners. This is there. Then again, it requires further improvement. Some issues are there, already I have told, and some more things which I used to speak. Of course, that climate resilient technology is required, but we do not know how can we define, can we calculate the resiliency. There is a need, for example. Then also we need to work on some of the things, for example, that I think personally that there is may not be required that the cotton ball should completely flower and then we should harvest. There should be some index to calculate, and can we harvest, can we pick that ball when it is 100% mature, and that ball is itself is a very, very good live material. So after 1 or 2 days it may flower fully in the farmer's house. In that way also we can reduce the cost. Then we have to develop the model to calculate the complete resiliency. And we also talk the stress. We have many tools to calculate and find out the stress, cause of stress. So we have all the climate scientists are there. We have to find out the complete level index of stress, how much stress and what actually is the causing the stress, and at what level in digital form. If we can calculate, we can predict, then we can pinpoint directly using the instrument. And also the variety, people who are developing the variety, for them also it will be very good. So formation of task force on cotton mechanization encompassing all stakeholders from public and private sector is required, and we have already formed, as I told in the morning, particularly for harvesting purposes. Formation of comprehensive mission mode program on mechanization of cotton cultivation, harvesting and ginning, comprising of stakeholders to make cotton mechanization in India a reality. Mechanization means mostly here we are lacking only for harvesting or picking. Undertake a pilot project based on promising technology to develop a model demonstration unit, complete solution of mechanization in production and post-production both at the farmer's field, and establishment of pilot scale facility for cleaning and processing of mechanically harvested cotton to demonstrate the benefit of mechanization to stakeholders. These are the certain points which can be seen by the policy makers, and again, the very few people are working this, so manpower enhancement, of course, is required. Thank you, sir. I took very less time. This, I think, only 10 minutes. So thank you very much.
Thank you very much, Dr. Jha. Of course, you took less time, but you have made some very important points, very important points, particularly mechanization, which is so important for cotton. Friends, I'll be now requesting Eric to make some observations on both the presentations, if you can. Eric.
Well, first of all, I would like to thank both of the presenters for very interesting comments. I guess I'm going to talk about the first presentation, and I'll talk about the second. The first one dealt with the effects of climate change. One thing that was quite interesting is that climate change, I think, in total is bad, but it's not uniformly bad. The insights about how it affects pest pressure, for example, it can reduce pest pressure, or the comment that in some states it actually may help production in some ways, if I understood the slide properly. So I thought it was a very detailed and interesting description of the effects of climate impact on cotton production. And I think all the other basically sound regenerative practices, intercropping, dealing with drought, conservation, tillage, irrigation. I think one issue that we're definitely facing is this issue of the LCA, and I particularly liked your breakdown of how to improve an LCA, because as we all know, the cotton sector is kind of getting destroyed because of things like the Higg Index, for example. So I think that issue can maybe feed into some of our processes about the LCA. And in the end, I think cotton has a really powerful story to tell, and if even we start doing better, that story can become even more compelling. In terms of the second presentation, and again, I thought it was very interesting about the challenge of low yields, and in particular for smallholder farmers and the issue of mechanization in India, and looking at the barriers to adoption. I would propose maybe adding one more factor. And the mechanization is a very capital-intensive, lumpy investment. And one of the real challenges is getting somebody to commit to hundreds of thousands of dollars or tens of thousands of dollars. I mean, for the big units, hundreds of thousands of US dollars. And so one of the challenges is how do you overcome that big barrier to this lumpy, highly capital-intensive investment? It just so happens I have observed a company in Africa that has pioneered fractional ownership of these types of capital-intensive investments. And the company is called Hello Tractor. And basically what they do is they're working with John Deere. They basically have financing. And so farmers will basically rent time on a capital-intensive investment. So what it does is that if you're an entrepreneur who buys a tractor, and farmers can basically use it for the time period in which they have value for it, what it can do is basically de-risk a very lumpy capital investment and then make it more accessible. So I'm happy to sort of connect you or discuss it, but I think dealing with this access to finance issue could really remove a major barrier to increase mechanization. But again, I thought all the other points were really good. I just wanted to add another one. Thank you.
Thank you very much, Eric, for making your observations. Friends, again, we are not going to have a question-answer session or discussion at this point of time. That's what Dr. Prasad directed me to do. So we shall break for lunch now. But both the speakers will be available around. So maybe during lunch time or later, you can discuss with them if you have got any points for clarification or any more suggestion. So thank you very much, all of you. Over to the organizers. Yeah.
Thank you, sir. May I now request Honorable Chairman, sir, to kindly honor our distinguished speakers with a memento as a token of love and respect. To Dr. S.N. Jha, sir, DDG Agriculture Engineer. To Dr. S.K. Chaudhary, DDG NRM. I request Co-Chairman Dr. Eric, sir, to kindly present memento to today's rapporteur, Dr. R. Raja, Principal Scientist, CICR, Nagpur. Sir, on behalf of organizers, we would like to present memento to Honorable Chairman, sir, and Co-Chairman, sir, as a token of love and gratitude for successfully conducting this session. So for this, I may call upon Dr. R.P. Kachuru, sir, to present memento to Co-Chair, Dr. Eric, sir. Mr. Eric, sir. I request Dr. Nawawali sir to present memento to our Honorable Chairman, Dr. Himanshu Pathak sir, for successfully conducting this session. So we have come to the end of this session. I thank Honorable Chairman sir, Co-Chairman sir, speakers, rapporteur, and everyone who have joined this session. And thank you for being so wonderful audience. Next, DG sir and all delegates will go for exhibition opening. And after that, at 3 p.m. there will be technical session at respective halls. Thank you all for joining. Yeah, 2 to 3 lunch break will be there, and after lunch there will be technical session in respective hall. Thank you.